Answers. So, hopefully, yeah, sorry about that. I did spot the question missing. It's on yours, but I believe that I need to. So the actual question was, is it concave up, concave down? Give a reason for your answer. Well, remember, the general form of a quadratic is ax squared plus bx plus c. And we looked at, when we did that investigation, that this coefficient here, the a coefficient, the coefficient of x squared, if a is a positive number, it's concave up. If a is a negative number, it's concave down. Okay? Now, a number of people said it's concave down because of the negative. Now, the question is written such that that is not valid reasoning, because there are two negatives, and the negative we want is the -3. So we were looking for something like the coefficient of x squared is a negative. You could have been simplifying it to just because of the -3. That's kind of minimum I would expect, but I would have allowed you because of the -3. It's concave down, okay? But not because of the negative. All right? Make sense now? Remember we did that investigation? That should have been in your blue sheet, right? Concave up, concave down. Yeah. Maybe we need to add to it the coefficient of x squared is negative. So you should know terms like coefficient of x squared. What's the coefficient of x?
1.
Almost.
Negative.
-1. And the 2 is not a coefficient because it's not affecting an x. It's a constant term, is what we call it. Yeah? This is a term in x squared with a coefficient of -3. This is a term in x with a coefficient of -1. This is a constant term. Okay. All right. Question 2. Find the coordinates of the vertex, find the equation of the axis of symmetry, determine whether it's concave up, concave down, find the y-intercept. All of those answers could have been found by just chucking it into your calculator and graphing it. Okay? However, you don't need those noises, right? Yeah? However, you would have got slightly more credit in terms of your knowledge and understanding if you used a non-graphical approach. Okay? But let's pick up on what we can do. Let's just do the things we can do straight away. Concave up or concave down? Down. We don't even have to say y, but it's negative. Yeah? Y-intercept? -11. Straight in there because of this number. Okay? Coordinates of the vertex or axis of symmetry first. Well, the axis of symmetry is x equals -b over 2a. You have the equation, yeah? You have the formula. You wrote it down. It's on your sheet. Use it. Saw a lot of people using it. -16 over 2 times -8. That's not quite good enough, because actually that is -16 over -16, which is 1. X equals 1. Simple as that. All right? Then how do we, so equation of the axis of symmetry is x equals 1. How do we find the coordinates? No. We could. We don't have to do that. If I know the vertex is at, the axis of symmetry is x equals 1, I know the coordinates of the vertex is 1, something. So I just put 1 in. Y equals -8 times 1 squared plus 16 times 1 minus 11. So that's -8 plus 16 minus 1, and that is -8 plus 16 gets you up to 8, positive 8. Positive 8 minus 1 is 7. So the coordinates are at 1, 7. Alright? So that is kind of what I was no, not expecting. That was what I'm hoping for. But the minimum I was thinking of was throw it into your calculator. I even told you, remember to use your calculator, right? Chuck it into your calculator. I don't need to go through how to use your calculators, no? Those of you that have regularly got your TI Inspires on you, well, do that then. Yes, that's the last time you're allowed to say that. Yeah. Whoever said picking out on Miles not having his. No? The other option was to get your laptop out and put it on decimals. No one did it. Okay? Who did the calculator version? Okay. Good on you for having the what's the word? I don't know. For doing it. But for at least going, I can't do this any other way, I'm going to go. Factorise the following. So what we do...
Wait, Mr. Fox.
Yeah.
Could you just go back over real quick?
It's all on video. You can watch it afterwards, yeah? You know, your committed self, you'll go back and review the video and write it all down. Alright? If you've got questions, please stop me to ask questions. X squared plus 8x plus 15. We should go through the steps. Is there a common factor that we can take out? There's no x in that one, so no.
3 and
There's no 3, there's no common factor. So we know it's one of the ones that's going to end up with double brackets. So what do we do? Well, we remember it's this number times, so 1 times 15, 3 times 5. It's going to be 3 plus 5, so it's x plus 3, x plus 5. That's the shortcut way. There is more to it if we need to, but remember what we have done when we were back in absolute basics. We were doing the grid method, right? And we were doing the grid method for expanding. And I said, well, factorisation is the reverse. So we've just got for 8x squared and 15. Okay? We therefore know that's x and x. What multiplies to make 15? But we then need to split the middle term. So basically, splitting the middle term is always what we do. We just don't need to worry about it at this level. But we need to split 8x up between two boxes with two numbers that make 15. So the plus 3 and the plus 5 gives me plus 5x plus 3x, yeah? That's what we do. So you could then know that those are your brackets, which we've got. So it's like that. All right. First off, is there a common factor? That common factor is x. So we start off with doing x times, well, x times x gives me x squared, and x times minus 3 gives me minus 3x. Is there anything else needed? No, that's it for that one. That's the one I remember saying to you in class. Don't forget about that. The basics. The taking a common term out. Don't forget to do that. That should be your first check. Next one. No common factor. Two numbers that make I don't need to do that because I recognise this as a square number. Therefore, I'm thinking about perfect squares. Now I don't need to know about perfect squares, but if I do, it helps me go quickly because I'm going to go, that's going to be an x with a 6 and a 6. And because it's minus, it's going to be minus and minus. Or x minus 6 squared. Either or, doesn't matter, but 6 times 6, negative and negative gives me the positive, negative 6 plus negative 6. So we could have just done it that way as well. But if I do remember about perfect squares, maybe I get there 30 seconds fast. All adds up. Any questions? Next one. Is there a common factor? First question. Ben, what is it? 3. So we divide each one by 3. So there's the 3. 3 times a squared plus 2a plus 1. Now often, that's where people stop. But I remember saying to you in class, always double check. Does this now factorise? Right. And because of the previous one, this box done again, is another perfect square because 1 is a square number. So we end up with a plus 1, a plus 1. Or a plus 1 squared. Yes?
So when would you do that method of moving the common factor? And
Always try to take the common factor first. Always.
If you can't, that's when you do
That's
it.
when you go to the next step. Yes. So I noticed for you, you did. By the way, not just you, lots of people did the splitting the middle term, which is absolutely fine. 3 times 3 is 9. All right, 9 is 3 times 3. 6 is 3 plus 3. So we have 3a squared plus 3a plus 3a plus 3. Split the middle term. 3a, a plus 1, a plus 1 times 3, that gives me 3a plus 3 times a plus 1. Great, fun. Almost absolutely good. Almost. But what's missing?
Not fully.
It's not fully factorized because if you look at this one, there is also a factor of 3 that can come out of that, yeah? So it would be 3 times a plus 1. That would be this bit times a plus 1, which gives you exactly what you had before. Here.
Couldn't it be a plus 1?
So this a plus 1 is that one, yeah? This one can be factorized into this. 3 lots of a plus 1 is 3a plus 3. Do I get a second a plus 1? That's why it's easier to have done the factor of 3 out first. So we can try and remember to do that. But lots of people did well with the split in the middle term, but just didn't take that final factor of 3 out. All right, this next question, just because I did say to you, at some point, there may be ones that don't factorise, doesn't mean 5 of the questions in a test are not going to factorise. All right? Well, some of you just thought, I'm just going to answer doesn't factorise whenever I fancy it. Right? This is what? An example of what? Difference of 2 squares. Where are the clues? A minus and a square number. Makes me think that. Yeah? And if you've written it down, you know a minus b, a squared minus b squared is going to be a plus b, a minus b. That maybe should be on your sheet. Therefore, this is x squared minus 5 squared. Therefore, it's going to be a plus, not a, x plus 5, x minus 5. Now, the other way to think about it, if you need to, is to say, well, it's x squared plus 0x minus 25. So 2 numbers that multiply to make 25 and add to make 0. Well, that would be plus 5 times negative 5. And plus 5 add -5, makes the 0. We never really bothered with that because it's easier just to do the, I think we did explain it, but. Any questions? No? All right. This one now then. Is it the difference of two squares again? Square number, squared, square number. Difference. All right? Remember, this needs to be something squared minus something squared. So this bit's easy, 3 squared. 81x squared is what squared? 9x, all squared. Okay, we did go through one of these. Therefore, it's going to be 9x plus 3 times 9x minus 3. Now, I wasn't worried and I didn't mark this wrong. Actually, we could factorise this even further. To divide, I could make this one 3 times 3x plus 1, and this one also 3 times 3x minus 1. Yeah? What does that become? 9 times 3x plus 1 times 3x minus 1. Well, that leads me to think, well, up here, could I have done what I've been telling you to do all along, which is there a common factor first? 9. So I could have said it's 9 times 9x squared minus 3. Is that right? No. So it's minus 1. Is that still the difference of two squares in there then? Yeah. Square number, squared, difference. All the clues are there. Okay? I remember saying to you, practice, 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 and you'll get really used to seeing this one. Okay? This is one of those things where the more you can practice, the better off you're going to be. So we end up with this as, this by the way, if you did this, I was perfectly happy. Alright? If you did this, you'd have blown me away. Okay? Any questions?
How do you know when the use pattern happens?
There's never a not. When you say, how do I know when to not bother trying? There's never that. You always try that. It either works or it doesn't work. If it does, great, and then see if the remaining factor can also factorise further. If it doesn't have a common factor, you then see if it can be done in the two brackets, or the difference of two squares. But you should always try to take a common factor out first.
That on back to that.
Yeah, no,
Right.
I've done that. I've taken a common factor out. What I would now do is look at that and go, it's the difference of two squares. So this is 3x minus 1 times 3x plus 1. That's the bit in there. And I've got the 9 that I've already taken out. So I ended up with the same. Here, look, I didn't take that out. But that's because of the question, the level of the question that it is. It's quite a tough one. All right. Let's go through that process again. Step 1 is to do what? Is there a common factor? Yes or no? No. All right. Now we know we're going to end up with double brackets. What method do we have when we've got more than 1x squared? Split the middle term. Talk me through it. 2 times 10 is 20. It's a positive 20. This is going to be a negative, which means both have to be negative. minus 1 times minus 20, minus 2 times minus 10, minus 4 times minus 5. Which ones add to make minus 9? Minus 4 and minus 5. So I'm going to write it down. 2x squared minus 4x minus 5x plus 10. And remember, at least one, if not two people were doing this right and then writing something different when they wrote this line. Split that, factorise. Lots of you were asking lots of questions about this the lesson beforehand. Even though we've done a lot of practicing, suggests that you still need to go back and practice. So I'm going to take this bit and factorise it. How do I factorise? Is there a common factor? So if I look at 2x squared minus 4x, is there a common factor? What is it?
2x.
2 and x. And that gives me x minus 2. Okay? Then I take minus 5x plus 10. Is there a common factor? 5? Yeah. What if we did my 5? That would give me minus x plus 2. Now, Matthew's got this because he's already said, actually, we could take a factor of minus 5 out instead. Why would I do that? Well, because I want this bracket and this bracket to be the same. So if I take a minus 5 out, what does that do? Well, it makes it x, and minus 5 times minus 2 gives me the positive 10. Right? So now what I'm going to do is I'm going to replace these two with these two. So I've got 2x times x minus 2 and minus 5 times x minus 2. What do I do now? So I have to factorise again. What do I do when I try and factorise? I take out a common factor. What's the common factor in this? X minus 2. So let's write the x minus 2 out. What's left behind? 2x minus 5. There you go. Okay? Questions on that? Need to practice. There's plenty there in your book that you've been working on. What we'll do the remainder of this week is we'll kind of pick certain things and we'll try and work through. And then write it in vertex form. We're going to get through enough. Which one would you like to do? This one or this one? 5. Okay. What does this mean? It's negative 3 times x plus 2 squared. So what I'm going to do is I'm going to work with the x plus 2 squared bit first. What does that give me? X squared plus 4x plus 4. Because it's x plus 2 times x plus 2. Okay, so I now have negative 3 times x squared plus 4x plus 4 plus 1. Now I'm going to expand the brackets. Negative 3 times x squared is negative 3x squared. Negative 3 times 4x minus 12x. Negative 3 times plus 4 minus 12. I've still got plus 1 on the end. That gives me minus 3x squared minus 12x minus 11. That, by the way, was like the 7-8 question that I've not shown you how to do, but you should have enough knowledge and understanding that you fully understand. So that's why I chucked that one in. I know we haven't specifically done those, but they're in the textbook if you'd have got to that stage. The previous one, I'm sure we've done enough practice, so you had that homework all on that. Need to check. And the final question, if you were good enough to chuck it into your calculator, you've got it really easily. It'd be nice to talk about that one next time if we could do it without a calculator, because it's just logical thinking, to be honest, even without a calculator. Right,